Hello viewers, this lecture is on how to solve the numerical problems on bankers safety algorithm. Okay, so in this algorithm we need to find out whether the system is in a safe state or not. Right. So in this type of examples, you will be given with number of processes. Okay, how many number of processes are there? Then the maximum demand that the processes may claim during their execution. Then the present allocations to these processes. Okay, so that is given as an input. Okay, as a resource allocation state of the system, and then what you need to find out is whether the system is in a safe state or not, right? So consider this example here. So here there is a system with 5 processes P0, P1, P2, P3, P4 and 3 resource types. Okay, suppose these resource types are named as A, B and C. You know that there are number of resources like printer, tape drives and so on. Okay, so these are the different resource types, right? Now assume that resource type A has 10 instances, B has 5 instances and C has 7 instances. So these are the different resource types A, B, C. Now suppose at time t0 the following snapshot of the system is taken. Right? So actually we are referring to this snapshot of the system. So what I have done is that I have written here the snapshot of the system. Okay, with maximum demand and allocations for each process. Okay, so this will be given, and what you have to do is you have to find out whether the system is in a safe state or not, right? So this is what you need to find out, right? Now just write down whatever is given here. So we are writing here the total resources in the system, okay, are given here. So what is given that, for example, P0 is max demand is P0 may require 7 instances of resource type A, 5 instances of resource type B, and 3 instances of resource type C. So this is given. Similarly, for each process, this max demand is given, and I have written it here. Okay, this is part of the problem input, and these are the allocations. This is also part of the problem input, right? So what you need to find out is that this 1057 is given here. Okay, so I have written it here, and here what you do, you find out the sum of each column, right? So the sum of this is 2 plus 3 plus 2. Okay, 2 plus 3 5, 5 plus 2 is 7. Okay, so like that, this is the sum is 2, and here the sum is 2 plus 1 3 plus 2 5. So this sum is first you have to find out. So available is calculated as total number of resources minus sum of allocations. 10 minus 7 is 3. Then 5 are the total resources of type B, and allocated are 2, means remaining or available is 5 minus 2. So 3 are available for B also, and total resources of type C are 7 and allocated are 5. So 7 minus 5 is equal to 2. So this is the your available vector, right? So these are the resources available. Now what this algorithm says, we have already covered this algorithm in the previous lecture. So initially you have to take this work vector, right? So work vector you have to take, and that you have to assign it to available. So it should be equal to, so 3 3 and 2. Okay, so just you have to copy this 3 3 and 2. Sorry, so this is 3 3 2. This is copied here. Okay, now what you have to see is that you have to find a process such that the finish of I is equal to false and need is less than or equal to need of finish of I is equal to false and need of I is less than or equal to 1. So what does it mean? That initially all the processes have set the flag to uh, false, right? And if you find a process that can complete with these given resources, available resources, then we'll make that process as, we'll mark here as the process finished in this particular column, right? Now we have to find a process. Now initially all the flags are false. Okay, so finish of Y is equal to false means the first, if you take the process P0, its flag is also false, it is not completed yet. Okay, so now what is the requirement of this process? Okay, the so that you have to find out here first the need equal to max minus allocation. Okay, so this, so the next you want to find out this need. Okay, so need equal to max minus allocation. So what is the max for P0? It is 753. Okay, and what is the allocation? It is What is the allocation to this process? 0, 1, 0. So that means what you have to do is you have to subtract this vector from this vector. Okay. So 7 minus 0 will do max minus allocation. So 7 minus 0 is 7. Then 5 minus 1 is 4. This is 4. And 3 minus 0 is 3. Okay. So this is 3. Right. So this is we have found out need equal to max minus allocation. So need vector is equal to this max vector minus allocation vector. Okay. So this is what we have got. Okay. Now next, similarly we have to do it for all, right? We have to do it for all. So just we can do this. 3 minus 2 is equal to 1, and your 2 minus 0 is 2, and 2 minus 0 is 2. Okay. So this is need, remaining need. That means initially these were the allocation, but the maximum demand is this. So what is the remaining need is this minus this. So this is the remaining need for process P0. So process P0 still requires 743. Similarly, if you subtract 200 minus 322, you will get this. Right? 3 minus 2 is 1, 2 minus 0 is 2, and 2 minus 0 is 2. Next, similarly, you have to do 9 minus 3. This is 6. Then 0 minus 0 is 0. This doesn't require any resource of that B type. Then 2 minus 2 is 0, so this is also 0. Then next is 2 minus 2 is 0. Okay, it doesn't require now anything of type A. Then 2 minus 1 is 1. Okay, and then 2 minus 1 is again 1, right? Then next we are having 4 minus 0 as 4, then 3 minus 0 as 3, so remaining is 3, and 3 minus 2 is 1, means remaining it still requires one more resource of type C. Okay, so this is what is the need. So need is equal to max minus allocation. That means this we are subtracted these allocations from max demand. Okay, so this is need equal to max minus allocation. So this is completed. So first we have find out this by using this formula, available equal to total minus sum of allocation. So we have found out sum of allocation, and now we have found out the need. Now what you have to do is that we have already assigned this work to available. Okay, so this is same as this, and now your algorithm starts. Okay, now you have to find out the process which can complete. So what is work means what indicates what is available right now. So 332 are the instances available for A, B, C respectively, and you check one by one which process can complete. Now let us consider P0. What is the P0's remaining need? It is 743. Now what you have to check is that whether 7 is less than 3, 4 is less than 3, and 3 is less than 2. So if it is true that this vector 743 is less than or equal to this work vector 332, then only you can say that this process P0 completes. Now you can see here that the requirement of the process P0 at remaining requirement is 743, which is much greater than 332. Okay, it's not less than or equal to. Okay, so here you have to compare each component of this vector. 7 is compared with 3, 4 is compared with 3, and 3 is compared with 2. So when all of them are less than or equal to this each of these components, then only you can say that this process can complete. But you can say that you can see now that P0 cannot complete because the condition is not satisfied. So our condition is what? Say it is written here. Need is less than or equal to work. So this need, okay, it should be less than or equal to this vector. So it is not the case. So P0 cannot complete. Now let us take the P1. So P1 is 1, 2, 2. Now is 1 to 2 less than 3, 3. Now you can say 1 is less than or equal to 3, 2 is less than or equal to 3, and 2 is less than or equal to 2. So hence the P1 can complete. So P1 can complete. So I will write down here P1. Okay, I have written here P1. Next is here now if P1 can complete now then the P1 completes. What will happen? P1 after finding Pi, what we are doing, work is equal to work plus allocation of I. So whatever was allocated to process P1, that is 200, this will be returned by this process. Okay, so these resources will be returned by this process, thereby increasing this 332 by 200. So that means you have to add this 200 to the 332. So you add this, so you get here 5. That is 3 plus 2 is 5. Then your 3 plus 0 is 3, and this 2 plus 0 is 2. So this is what is now available. Okay, so available has increased because P1 is completed. So P1 will release these instances. Okay, 200, and it will you added to this and you will get this, right? Okay, so what you have done, 3 plus 2, then 3 plus 0 and 2 plus 0. So this is what we have got. Now with this work vector, now you have to again start from the beginning. Okay, so there are multiple ways to proceed further. You can start again from process number 0, or you can continue with the next process also. So we will take this approach that we will always start from the process number 0. Now again we will go to process P0 and check whether this 743 is less than or equal to 732. So no, still it is condition is not satisfying. So we'll come to the P1. So P1 is already completed. Next we'll go to P2. So P2 is having the requirement 600. So is 600 vector less than 532 vector? No. So this also cannot complete. Okay. So next we'll move to P3. Now P3's requirement is 011. So is 011 less than 531? Yes. So that means your P3 can complete. So I will write that P3 will finish. So when P3 finishes, what was P3 having? 211. So it will return back to the work vector. Okay, so available. So 211 will be added to this 532. So 5 plus 2 is 7, right? Then 3 plus 1 is 4, and then 2 plus 1 is 3. Okay, so that is the addition we have done because P3 is completed. So P3's allocation vector is added to the work vector to reflect that now more resources are available because P3 is finished. So its resources are added, okay, or they are reclaimed or returned back, okay, to the operating system. So now they have increased. Okay. Now again we'll start with the P0, okay, and check what is the P0's requirement. 743. So is it less than or equal to 743? Okay, is need less than or equal to work? Yes, so 743 is less than or equal to 743. It is true. That means P0 can complete. Okay, so I will write here P0 can complete. So I have written here P0. Now, if the P0 completes, what P0 is having? Allocations 0, 1, 0. So add the 0, 1, 0 here. So this becomes 7 plus 0, 4 plus 1 is 5, and 3 plus this 0 is 3. So this is the now resources right now available, right? So P0 is completed. Okay, now again we'll go from the first process. P0 is completed, P1 is completed, but P2 is not completed. So let us compare P2. Okay, so P2's need is 0, 0. So is this need less than or equal to work? Yes, it is less than or equal to work. That means P2 can complete. So let me write here that P2 is completed. So if the P2 completes what it was having 302, so add this back to this. So if I add this, so 7 plus 3 is 10, and 5 plus 1 is 6, and 3 plus sorry, we are doing it for P2. So be careful here. So we are adding 7 plus 3 for P2, then 5 plus 0 you have to add. Here you have make mistake, so it is a 5. So you have to be careful here. And then this is 3. Sorry, this is P2 is having 2, so 2 will be added to this 3, so give you 5. Okay, so this is the thing you have got. Now you can see that again if you go back P0, P0 is completed, P1 is completed, P2 is completed, P3 is completed. You can see here these are all completed. Only remaining is P4. So see what is the P4's requirement. So P4 needs 431. So 431 is 431 less than 1055? Okay. So 431 is a vector, not a number. So is it less than 1055? Yes, that means P4 can also complete. So let me write here P4. Now if P4 finishes, what it will do? It will return the 002 back to the OS. So this will become now 10 plus 0, 10, 5 plus 0, 5, and 5 plus 2 at 7, right? So I have already, so see, I will write here 7, and you can observe as soon as I enter 7 and press enter here, what happens, right? So here I have written a small actually uh, code here in Excel sheet. So it says that verified found okay. So as you have to actually do it on the paper. So when you do it on the paper, you have to check that whether this 1057 is equal to this total resources in the system. 1057. So this 1057 must match with this 1057. So if it matches, that means you have solved the problem correctly. So you can immediately understand whether you have solved your problem correctly or not. So this 1057 must be equal to this 1057. So here it is matching, so that's why I have written here verified how okay, right? Earlier this was not there. Now this is the, and also it is saying that safe sequence is P1, P3, P0, P2, P4. So whatever is this sequence is called as a safe sequence, and hence the system is in a safe state.